Hi, welcome back to our Algebra 1 series. On this video, we're going to look at how to fill out a table of values, how to graph, and how to find the domain and range of a radical function, in this case, a square root function. So please remember that you need to use your order of operations when you are simplifying these expressions. Now, I gave you the left column, the x values that you need to substitute in to solve or simplify. So I'll substitute in my -9 plus 9. And please make sure that this plus 2 is not under that radical. Now, when I simplify, -9 plus 9, that's the square root of 0. Well, the square root of 0 is 0. Plus 2 means my final answer is 2. All right, let's try another one. -8 plus 9, and then plus 2 not under the radical. And if -8 plus 9 is difficult for you mentally, I always have to think of this as 9 minus 8. You can switch that. It's commutative. You can switch the order. That's the square root of 1, which is just 1, plus 2. That gets me 3. The next one I've got here, the square root of -5 plus 9, which is really the same thing as 9 minus 5, plus 2. And here's a mistake that a lot of students will make. They'll take the 9 minus 5 and they'll put 4 plus 2, but that's not correct. What did they forget? Well, they forgot to take the square root of 4. And that's a really important step. I see it all the time. So the square root of 4 is 2, and 2 plus 2 is 4. And then the very last one, 0 plus 9 plus 2, you have to remember to take that square root of 9, which is 3 plus 2, and that gets you 5. Okay, now let's take a look back at our original function. I could tell you right now that the vertex is -9, comma, positive 2. And usually I would encourage you to find the vertex first, because if you find that vertex first, well, look at that. Your first set of coordinates here is -9, 2. That's your first set of coordinates. Now this is an 8x8 graph, so I'm going to have to go off the grid a little bit. -9, comma 2, there we go. -9, comma 2. -8, comma 3. -5, comma 4, and 0, 5. So I've got this nice curve. There's my square root function. It opens up because a is positive. It went left 9, up 2. And the domain and range, another good reason for having that vertex found first is because your domain and range, once you've got the domain and range, that's going to come from your vertex. And you know what? I'm going to tack that on to the very end of this video. Let's just keep rolling with our simplifying here. So I gave you the x's. Why don't you take some time here? I would pause the video, try substituting in these numbers, simplifying, and then unpausing and check your work. So -3 plus 3. Make sure that -1 is not under the radical. -2 plus 3. -1 not under the radical. Okay. So first thing we need to know is, really that's the same thing as saying 3 minus 3. So square root of 0 is 0 minus 1. 3 minus 2, well, that's 1. Square root of 1 is 1. Minus 1 is 0. 1 plus 3 is 4, but you have to take the square root of 4. You have to take that square root. That's 2 minus 1 is 1. And the square root of 9 is 3 minus 1 is 2. So let's check our vertex one more time, just to make sure. -3 comma -1. And hey, look at that, -3 comma -1. So I'll go left 3, down 1, left 2, up 0, what is it, 1, 1, 1, 1, 5, 6, comma 2. And I'll do my best to sketch this graph. That doesn't look half bad. It opens up, A is positive. I've got my vertex at -3, -1. Everything works out there. Okay, now 11, another tough one because there's this thing out front, this A value of 2. My vertex is -1, -1, which means that when I substitute in those values, I should get -1. But let's check just to make sure. Two times -1 plus 1 minus 1. And remember, you've got to use that order of operations when you're simplifying. So first thing I would do is my parentheses, my square root or the radical. So -1 plus 1, that's the same as saying 0. So I have 2 times the square root of 0, which is just 0, minus 1. Well, this is 0 minus 1, and that does in fact get me -1. So that's good. Let's try another one. 2 times the square root of 0 plus 1 minus 1. Well, that's the same as saying 2 times, what's the square root of 1? Square root of 1 is 1 minus 1, and then I got to simplify. So 2 minus 1 is 1. I would encourage you again to pause the video here, try those last two, and then unpause and check your work. So I get 2 times the square root of 3 plus 1 minus 1. That is the same thing as 2 times the square root of 4 is 2 minus 1. 2 times 2 is 4, minus 1 is 3. And then our very last one here, 2 times the square root of 8 plus 1 minus 1, which really means 2 times the square root of 9 minus 1, and that should get me 5. All right, let's see what happens when I graph this. -1, -1, 0, comma 1, 3, comma 3, and 8, comma 5. All right, when I go to graph this, that is a much taller graph. I think I'm gonna have to, there we go. So I got 2 questions for us. Number 1 is, why is this graph so much taller than the graph that came before it? And the answer there is because I've got an A value of 2. There, my vertical stretch made it twice as tall as a normal square root function. And if you made some mistakes, I would probably guess that you forgot to take the square root of 9, or you forgot to take the square root of 4. That's a pretty common error. I would check your work one more time if you made any mistakes. And now let's talk about domain and range. So domain is really your x values. It's saying, what x values does my graph cover? Range is just asking what values do my or what values on my y-axis are covered, rather. So on the x-axis, where do I start? So left and right, where does this graph start? All the way on the left, it starts at -9. And notice that your vertex starts at -9. Well, what other numbers are covered? -8 is covered, -7, -6, all of these numbers are covered. On my number line, I'm going to the right. I'm starting at -9 and I'm going to the right, which means that I'm getting all of the numbers that are at -9 or bigger. Because if you think of a number line, if you started at -9 on a number line and you went to the right, you'd be getting bigger numbers. When you go to the right, you get bigger numbers. For the y, where did I start? Well, how high up did I start on that number line? I started 2 above the middle. I started at +2. Well, how else could I have known that without graphing? I can look at the vertex. That number comes from the vertex. I started at 2 for my y. And if I went up on the y-axis, if I'm going up, is that going to get me numbers that are bigger than -2 as I go farther up on the graph, or am I getting numbers that are smaller than 2? Well, if I'm going up on the y-axis, that would get me numbers that are bigger than 2. So my x values, I started at -9 and I got bigger numbers. The y values, I started at 2 and I got bigger numbers. All right, let's try another one here. The domain on this one, where did I start left and right? So how far left on that graph did I start? I started 1, 2, 3 to the left. I started at -3, and if you check out that vertex, that's where my vertex tells me I started. I started at -3, and I got all of these numbers that were traveling to the right of that vertex, which means that I was getting the numbers that were bigger than -3. For the range at y, I started 1 below the middle. I started at -1. And again, I know that because if you look at the vertex, y was -1. And this graph goes up. So if it goes up, that means that I got bigger. And our very last one here, domain, my vertex tells me that I started at -1 on the x. It tells me that I started at -1 for the y, for the range. I started at -1 to the left and I went toward the right, which means I got bigger numbers. I started at -1 on the y-axis and I went up, which means that I got bigger numbers. So this one, the x will always be greater than. The y, however, can change because I could have a graph that goes down. And if I were going downward on that y-axis, that would mean that I was getting smaller numbers. My numbers were going to the left, they were getting smaller on a number line, or they're going down on a vertical number line. So if it's going up, here we can see my numbers are getting bigger on the y-axis. If it were going down, it would be less than. Check out the other videos.